Okay, today we're going to be talking about the sequencer that controls the door opening and closing and activates the leg walking mechanism. Of course, this is the part that you've seen. I've done a short on this, and I've talked a little bit about it in another video. Basically, what we're looking at here, let's start with what's driving it. I'm using an N20 gear motor, and this particular one, if the camera focuses on it, you can see that it's the 3 volt and 15 RPM. So I was about the slowest that I could find of the front drive. You can get some on the right that have a worm gear that go even slower. But this is the one that I had, so this is the one that I used. And basically it's slid in here. I know you can't see anything with all these wires everywhere, but you have to trust me. It's in there, and there's a little screw that I screw into the plastic to hold it so it can't come out. So on the shaft side of that little gear motor, there's this disc which has a lobe sticking out for hitting this switch. Now this spring is what I'm going to be using to open and close the door, and the reason I decided to use a spring was if someone was holding this and is trying to open the door, I didn't want to break the mechanism or anything like that, because I'm not really going to get back in there once this thing's all glued together. So with a spring, it can bend and collapse like that if someone jams the door, or if their finger's there and the door is closing, then the spring can stretch. So I decided to use a spring to come out to where the door is going to be from this mechanism. And this mechanism fits on the inside. I kind of covered that in the last video, how that's going to sit in there. And so the reason for this little lobe that you see sticking off here, and this micro switch, is this lobe obviously is what opens and closes the door, but I need it to be able to stop. And I want, when the door is opening and closing, the walking to stop, and when the door is closed, I want the walking to continue. So I'm going to use this little micro switch, which you can see the leaf here. I'm going to manually turn this so you can kind of see this better. So you can see this leaf moves in and out. Now these micro switches have 3 connections. They have what's called the common, which is down here in the bottom, and then you've got a normally open and a normally closed. And what that really means is when this leaf is out, like it is right now, nothing's pushing on it, this common is electrically connected to the normally closed. So that's just like a straight wire. And when that lobe comes around and pushes on it, then that common is no longer connected to the normally closed. It is now connected to the normally open. So power is now diverted to here. So basically I've wired this up so that if this is in this position, the common goes to the normally closed, which supplies power to the little N20 motor. So this motor is going to want to run, and it's going to run all the way around until that lobe hits that switch and pushes it in. When it pushes it in, then the motor will stop running, and then power will be diverted to this normally open connection, which will give me power to the TT gear motor, so that the leg walking can action. You're going, yeah, but once that happens and it comes around and stops, what's going to make it cycle again? Well, to make it cycle again, I need to have another wave supplying power to that N20 motor momentarily, just to get that nub past here. To make that timing happen, there's a separate timer circuit. And I'm going to show you what this looks like, because you can't tell with a bundle of wires. But this right here is a very inexpensive board you can buy that has a 5.5 timer chip on it, and has a trim pot, this blue thing that's hiding in the bundle of wires. Again, like I say, I'll show you right now actually, so you don't get too confused. This is the one that's being used in the device. It's larger than I wanted, but it came first, so that's the one that's in there. This is the same thing that you can get from other vendors. That's smaller. They stack the trim pot on the back side and put the timer and the resistor chips and all that kind of stuff on the bottom side. This will work just as well, and I'm going to demo this for you in just a second so you can see how it can just as well. The one thing you have to do to these, though, is none of them give me the length of the time that I needed to make this work. I'm going to talk more about that in a second. Before I get that far, these being a integrated circuit thing, they need a clean power supply. I'm running the whole toy off to AA battery, so I have 3 volts, and it isn't going to be clean when it's running motors and flashing LEDs and stuff. So up here on top, I put in a little voltage boost circuit. This will take, I really don't know if the camera's focusing or not because I can't see the viewfinder, but it'll take the 3 volts in and ground and give you a clean 5 volt output. Even if the voltage going to this from the batteries were to drop as low as 1 volt, this would still give me a clean 5 volt out. So this little booster is supplying clean power to the timer board, like that. And then the timer board, when it gives me the pulse that I want, it's not a square wave, it's just a pulse, is going to drive this. In this case, I'm using an N-channel FET. This is way overkill, this big device. These little TT motors only draw like 20 or 30 milliamps. I could have used an NPN transistor like here in the States. One of the most common would be a 2N222A or a 3904. Either one of those would have worked just as well. But again, this is what I had. I had a power MOSFET, so that's why I'm using the MOSFET. The timer will turn the MOSFET on. The MOSFET will connect the ground back to the N20 motor just for about a second or two, enough to get that little nub past that switch. And once the switch is open again, that supplies the motor to the N20, and it continues to rotate till it comes back around and hits and stops there. So I need the timer set to not only accommodate the length of time that it takes for the door to open and close, but also the time that I want the walking action to happen. So the total time of those two. In this case, I was guessing I would want something around 14 seconds. Let me connect some power up here. There we go. So this came around and it stopped. So right now, this thing would be walking if this was wired into the TT gear motor. And after it's walked for, I don't know, 6-8 seconds, then the door would open and close again, and it would stop. And it will just continue to do that cycling, walking, 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 on, and walking stops, doors opened, doors closed, walking again. So that just continues like that. Like I said, here's the smaller 5.5 timer one that I showed you that arrived later, that I've modded. And this is just an LED light that I had laying around. I know it looks huge, but this will visually show you the mods that I added to this to get the timing that I need. So here, as soon as the light comes on, we'll start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So about 15 seconds counting at the speed that I just counted. But in order to achieve that, because this module isn't sold being able to go for that long of a period of time, and it isn't sold with a narrow pulse, positive pulsed output. It's basically a square wave. The on time would be as long as the off time, which wouldn't work, because if the pulse coming from that was long, this would just keep going around and around and around. So half the time the door would be opening, closing, opening, closing, opening, closing. Then half the time it would be walking. That wasn't what I wanted. So the easiest way to mod these, because trying to solder on this little teeny micro stuff that most of us can't even see, we've got to be able to get out to these pins where we can see what's going on. So in my case, this isn't critical. I had a 47 UF electrolytic capacitor. I know that this was ground, so I took the negative side of that capacitor and soldered it to the ground lead. And the positive side of the capacitor, there are 3 leads coming off this trim pot, and they come up through to this side of the circuit board where they can be seen here. So I soldered the capacitor to this outside lead, this bottom lead down here. And that's going to give me the longer timing cycle. I mean, I could, if my eyesight and soldering pen was small enough, this little capacitor right here by my finger, I could have soldered across that. Be dang near impossible for me to do. And just changed it there. But I did it out here because it was easier to get to it. Then we need to add a resistor and a diode, because we don't want a square wave output in this particular application. In this application, we want just a pulse. So I took a 10K resistor and went to the other side of the trim pot, bringing it up through the signal diode. It's an IN441. And to the anode side, hooked the resistor to that, and the cathode, which is the black banded side, to the same place that the capacitor was soldered on. And what that's going to do is give us that pulse that we needed. And what else? That's all that's happening back here. It just looks complicated because of all of the wires where I had to run things. I had to keep everything out of the way again so it doesn't get caught up in any of the mechanisms or the walking or the moving figures or any of that kind of stuff. It all has to be able to squeeze in there. This wire is going to end up supplying the voltage for the TT gear motor to turn it on and off. And these other wires are going to get the 3 volts. The black and the red are going to give me my 3 volts after the switch. This extra white one here, I brought out the rectified or boosted 5 volt signal since I already had it, because I'm going to use that to run the LEDs that I showed in the other video. Well, let me grab it. Again, it was just something that I had. White LEDs don't really start conducting till about 3 volts. So if you want to reliably run them on a 3 volt supply that's also running motors and other things, you really should just go ahead and boost it up to 5 or something. So at any rate, I'm going to bring that other white wire up to power these LEDs, so when this thing's installed, I can get some light in through these windows to help light up the little robot passengers on the inside. Now, I didn't include a light clear in the back to light up the back guys. I thought about it, but it just seemed like such a pain to put one more LED back in there and then route all those wires clear up to the front. So I just didn't do it. But there you have it. The next thing that'll be happening will be I'll install this mechanism into the frame. Let's disconnect it from the 3 volt power pack. And like I say, I showed this in the other video, but basically this is going to go in there all the way back. The spring is going to come out through this slot to get to the door. And like I say, this can be removed right now, but once this is glued in there, this won't move, won't be removable at that point. And so it's not really something I can do on camera, because I got to get glue on this surface and glue on this surface. This surface will glue to this back wall. You really can't see that. Let's see if we can get some more light on that. How's that? There'll end up being some glue there and glue up above from this. And those 2 glue points will hold this in place, but also keep this from moving. So it's more than I can do in front of a camera. I'll be holding a lot of this stuff on my lap to get that part done. But hopefully that helps understanding the electromechanical sequencer. It's not just a motor and a cam for opening the door. It was also a sequencer in that when the door function is done, I want the walking function to start. And when the timer says it's walked long enough, then I want the door to open and close again. Again, you could set that to any time you want by changing the added-on capacitor, the added-on cap. You can change that to any time you want. Plus, it does have a trim pot, which gives you some control. In this case, I did end up changing the setting from the factory to get it down to about 14 seconds, which is kind of what I wanted. I didn't want it walking forever in between cycles of the door. So, all right, I guess the next video I will either be gluing this on and giving you one last peek of everything installed, or it'll all be together and it'll just be a final demo of this unit working.